a safety issue. You probably, someone will want to read that stuff in 20 years' time. When you process XML, you should ignore any processing instructions in the XML. We argued about saying there shall not be processing instructions in the XML, but we backed away from that. We said there shouldn't be, and you shouldn't process them. And if you do process them, you better know what you're doing with regard to security, because it's easy to reach out into the XML stack and get it to do unpredictable things. So that's the base rules. But when it comes to XHTML handling, there's one tricky issue, which is that we allow external references for images and in cascading style sheets. There's all sorts of valid uses for those, but you should really whitelist the references that you allow. You should not leak headers. It's really easy for clients to leak headers, since it's mostly server developers that are on song with security. If you're a client developer, you need to really know what you're doing with not leaking headers. So you wouldn't want to leak someone's access token to another server by accident. And you should always check the media types of attachments. Attachments are just a whole world of risk to themselves, and we don't fix the kind of attachments that are allowed to be used, but they can always be an issue. Okay, that's the simple stuff. All right, now I'm going to talk about authorization, authentication, and access control. So there's quite a bit of confusion in this area. So just to get some terms right. Authentication is about who is the user at the other end of the request. The client might want to know who the server is, but the server definitely wants to know who the client is acting on behalf of, and potentially what the client itself is. Authorization is, what does the user allow in this context? And that's a really complicated, multi-layer thing. In the simplest case, you don't have a user, and so there's authorization sort of falls down into the security layer. But in the common case in FHIR, using OAuth, and the user, first of all, authorizes the application that you're dealing with to take some actions on their behalf. And then there's access control. Is this particular request allowed, given the data that's going to be covered by the request, the data that's in the request, the rights the user has, the authorization the user's given to the software for this context, and any rules on the underlying data. And one thing that's not obvious to anybody who hasn't written down inside the guts of a server, the security layer is not about approving or denying requests. It carries with you into your processing of the requests, and I'll talk a bit more about that later. So there's those three things: authentication, authorization, access control. They're easy to confuse, and they sort of overlap a bit operationally. So when you implement FHIR, I've got here a sort of a conceptual diagram. You've got a user at the top. The user has a client, which is represented in this case by a desktop. There's an access control engine indicated by the gears, and then there's a server that provides access to the resources using the RESTful API at the bottom, and the red line indicates a RESTful API. This is just a conceptual idea of where access control decisions might be made. So on the left, the user makes a request using their desktop, their application. It launches to a FHIR API and asks for the request. The first FHIR API is a specialist access control engine that inspects the request, decides if the user has the authority to execute it, and if it does, passes it on to a resource server that just does the work. That's the first simple model. The second simple model is actually the client decides for itself whether the user has the authority and just has a dumb server at the back end that does the service, and it just trusts the client. And the third option is that the access engine is down behind the API with its own connection to the resource server so the resource server can call directly on the access engine. So this is a conceptual model. Most production systems have all three models in them one way or another. There's a module inside the client saying, well, we know this is not going to be approved for you, so we're not even going to offer you the option. And so that's effectively running inside the client. And then most systems have a pre-filter, a model like this, where the access control engine looks at the request first of all and says, well, maybe we'll pass it on or not. But in almost every case, you end up with the access control engine down here as well. And so this is not like a recommendation to implement in any particular way, but just that, to think about how that works. One of the issues is, if I do a search on the RESTful API, and let's say I search patients, and so the engine looks at that and says, well, this user has the right to search patients. Fine, we'll let that through. And then the parameters include a reverse lookup onto observation, looking for a particular kind of observation, perhaps like an HIV observation. We've suddenly launched that query into a totally different space in terms of access control. And in fact, there's ways that I could express that query that aren't visible to an access control engine. They only become visible once you deep down inside processing search and following the chain, and you realise, hey, we've just walked into something really interesting here. And that's why the access control engine has to be inside the resource server. At least part of it has to be done down there where you're deciding which pieces of data you're going to depend on, you're going to have access to. So I had a lot of security experts tell me that this on the left is the correct model, but it's not the correct model, right? The resource engine that actually does the work cannot be separated from the access control engine. That makes sense to everyone? I'll take a little bit about OAuth. So OAuth is about delegating authorization. In most non-server developers' heads, OAuth is about delegating authentication. And a lot of people who haven't actually sat down and model out the flow for a server are pretty hazy on the difference between authentication and authorization. So the reason is because if I'm a resource server and I hand over to an authorization server and says, hey, what is this agent authorized to do in this context? The first thing the authorization server has to do is figure out who the user of the software is, so it can ask them and remember their decision. And so in effect, you hand over authentication. And in fact, OpenID Connect is built on top of OAuth and makes the authentication part explicit. But what you're actually handing over is the authorization. So what you do is you say, this agent that's contacting my server is representing a user of some kind. And what does this user want to authorize the agent to do? Now, in corporate environments, it's probably going to be the case that the IT administration will make that decision on behalf of the user. And the user won't even see this exchange going on. But the browser will just redirect to the server, to the authorization server. The authorization server, we already have made all these decisions straight back to the resource server, transparent to the user. But in other cases, it's not a central organizational decision. It's a decision made on behalf of the user, for instance, on the patient portal, where the patient says, well, I trust this application to access my medications, but that's it. Or most likely, I trust this application to read my data, but I'm not having it writing any data to this data repository. The OAuth is the interface is the same, irrespective of the kind of decisions that are going on. It's not necessary for the authorization server to identify the user at the other end. It's just normal, and it's usually a good idea. What I want to show you is two-layer OAuth. So this is what is not going to be, is going to be fairly common. Hopefully it's going to work. Okay. So we can go to my server. And on my server, it's going to, problem. Oh, here we go. Okay. So my server, I'm going to say I want secured access to my server. This is the same server as test.fire.org. So I'm going to say I'm going to log into the server and using OAuth. So my server is split into two parts, the resource server and the authorization server. And the resource server is just forwarded you to the authorization server, says, what is it you want? So the first step, my authorization server says, well, who are you? You can log in to me directly. On the other hand, you can log in through Facebook. So let's do that, log in through Facebook. And Facebook says, well, the server, which is now acting as a OAuth client, is asking for your identification information. So I say, okay, I'll give access to that. And now we get back to my server. And now my server says, okay, I know who you are. Now what do you want this agent, which is my browser in this case, what do you want that to have access to do? So back to the server. So there's two OAuth processes here. The first OAuth process is the user application, which in this case is my browser, going to the health records server and seeking permissions to provide access to health records. And the health records server says, well, hey, first of all, I want to know who you are. And you could just, at that point, log in directly to the health records server. But alternatively, the health records server says, no, I'll use your identity from some federated identity service. And so it becomes a client to a federated identity service running OpenID Connect, which will serve up identity information and handle your password. And so the health record server doesn't need to get into the business of handling passwords. Now, if you go back to where we were, and I'll go back a couple. My server's objecting to that, as it should. For fun, I have an option here that you can identify yourself to me personally, and then I'll enter your token that you give me into the table on the server, and you can log in without identifying yourself to the server because you identified yourself to me personally on Skype. And anyway, you are welcome to do that, but no one ever has. But you don't have to log in. Anyway, of course, if you're going to delegate the user identification to a federated identity server, somehow you have to be able to link from the identity information you get back from the federated identity server to a patient record, or records, plural, on your health record server. And that link can be made in a number of ways, by usually enrolling a patient at administration when they're actually present, saying, well, you want to give us a Facebook login or a Facebook identity or something like that. Or the best option is if it's a national federated identity service. Right? And there's a few countries that have them working, providing OpenID Connect services. There's more countries that have them, not yet providing OpenID Connect services. And then there's some countries that will never have them for political reasons. But, you know, that just spreads the pain around without actually solving any of the actual problems. So, back to OAuth. HL7 publishes a profile on OpenID Connect and OAuth called Smart App Launch, which nails down a few of the optional bits and specifies how you integrate the launch into an application so you can use it as an application extension framework. My recommendation is that you should always use this whenever possible as a general framework for handling authentication authorization issues. It's not perfect by any means, but it's very robust. It does impose some tax over a direct connection without any security or with, you know, shared secret-based security. It's more work, but it's much more robust once you've set that up. I want to talk a little bit about scopes. So when you connect with OAuth and the user authorizes an action, the language for exchange about what the application wants the user to approve and what the server has decided the user has approved, the language for the exchange between the resource server and the authorization server is called scopes. And a scope is a list of space delimited tokens that in the OAuth spec are not described. It's for private agreement between the authorization server and the resource server. Smart on FHIR defines a set of scopes, and the scopes are a class of access, either user or patient or system, followed by a type of FHIR resource, and then read or write. So examples is I'm connecting as a patient, I'm going to ask to read any kind of resource associated with a patient. Or I'm connecting in my user account, I want my user account to access anything that the user can read or write. I'm asking for full access based on my user account. And there's a few other scopes as well. These scopes, to me, the principal issue is where we are with Smart on FHIR. These scopes are extremely easy to understand and implement on a FHIR server. And so they're extremely easy to enforce, but they don't help a user very much. Right? If you go to a user and say, hey, you get on a patient portal, you're connecting an application maybe on your phone, maybe Apple Health Kit say, and you're connecting that to your EHR. Do you want it to have read access to your medication statement and your medication request and your medication dispense? And the user's going to go, what? I don't know. I want it to have everything but my psych details. Right? The Smart on FHIR scopes, Smart App Launch scopes don't address that kind of use case. This is my take on it, in that I look at the scopes that you've asked for, I categorize them into a set of slightly user comprehensible requests, and then group them up and approve them as a group or not, and then return what the application said it wants. But even this, I mean, this is there's a long way to go. And if you look at the various EHR providers' takes on this, again, there's a whole variety of takes on this. I think this is an area where there's a need for a really good set of research on this, so that we can start talking about how to bridge between what's easily enforceable on the API and what's actually useful to a patient. Recent discussions have suggested that there's a different approach, which is that you come to agreement with the patient, which you then capture in a consent resource. The patient consents using a consent resource to their actual sharing policy. It's much more rich language than the set scopes. And then the application would ask, instead of asking for a list of scopes, the application would say, well, here's a consent statement that identifies the kind of consent you should give in order to run this application correctly. And then the authorization server looks at the consent model that the application's asked for, and it looks at the consent model the patient has, and it says, you've already assented to that, that's fine, the consent, so we'll just redirect it automatically because you've already sorted that out. Or it might say, well, actually, no, you haven't consented to this, now you need to consent to this, and makes a new consent agreement with the patient, and then sends that back to the application and says, well, here's the consent arrangement you're working under. If you want, you can access the consent resource and see the details for yourself. And so it's possible that we'll start testing that at the January Connectathon in New Orleans. But that's a fairly recent discussion. There's a whole level of complexity more, but it's about trying to get at how do we manage this process of consent. The scopes in Smart on FHIR are too simple, but anything more complex than that is really, really hard. So I think of that as a research area for FHIR. The thing I need to talk about is access control. So the OAuth scopes, or the consent statement, they interact with the access control engine. So there's an access control engine sitting somewhere that has to decide for a given request, is this okay? And it needs to answer the following kind of questions. What scopes or consents can a user allow? What operations and data does the user have rights for? what scopes, what consent has the user allowed in this context, and what other consents and jurisdictional policies are applicable in this context. This is a serious piece of work, and going forwards, we're pretty much going to get to the point in a few years' time where actually serving FHIR resources is really straightforward, right? It's a walk in the park. All the fun and the value is going to be in the access control engine. I think that's where we're going to head. Now, the interesting thing is that FHIR does not standardise the access control system or layer. We don't even describe the users. We've had a regular, it's kind of like one of our most regular questions. Can you just add a user resource, please? No, we don't do that. There is an API called SCIM, Simple Cloud Info Management, SCIM, which my server uses for user management, and we recommend by default. If you want a RESTful API to manage your users, then use SCIM. We're not going to do that. And the other thing we haven't done is we haven't standardized a language for making access control assertions. We've kept away from that. So I'm interested in discussion, not here or now, but generally you could discuss on chat.fire.org or with me personally as to whether we should do that. There's some work in HL7 around standardizing role-based access control or so forth, and it's not the sort of thing that leads to interoperability quickly. Talking about audit event. So we have two resources, audit event and provenance. So as part of your security, you should maintain an extremely comprehensive audit trail. Extremely comprehensive audit trail. The audit event resource allows you to record login, logout, user authentication events. It allows you to record RESTful API transactions and also high-level real-world events. You should shower the audit trail with audit event notifications. This is a RESTful wrapper around, in the end, the ATNA protocol that IHE has been testing for a decade now. Typically, the RESTful servers allow you to create, but not update or delete from the audit event repository, but you can search it. And so we actually solved an outstanding issue for IAG, which was to provide read access to the audit trail. The audit trail is one of the most targeted features from insider attack. And insiders, when they decide to meddle with the audit trail, are extremely motivated and often quite skilled up. They can contract to get the skills. I recommend to all implementers that they should sign their audit trail. And this is one area where blockchain is actually potentially useful. If you sign your audit trail on a periodic interval, like every few hours, and then take the hash and put the hash in the public blockchain, it's really hard to fiddle with the audit trail after that. So that's one area where a public blockchain could be kind of useful. But certainly you should pay a lot of attention to that. The most skilled insider attacks consist of hacking the database and then trying to figure out how to hack the audit trail, and most of them get brought down because they didn't quite finish the audit trail. What that doesn't tell us is how many people did, because we won't catch them. The other resource that we have is the provenance resource. So they're kind of like in and out. The provenance resource talks about a change that we're making. An audit event records the change that we made. And so they're before and after. The provenance resource carries information about the source of the data in the set of resources being described, linked to, submitted as a transaction. And typically they cover what's called the W5. Who, what, when, where, why about this change. Why did you make it? Where did you get the information from? Maybe you got it from some other information source. It allows someone who's looking at the information to trace back and find out what the provenance of it was and whether it's reliable and trustable. If you look at the resource content that we have in the various resources, some of them include some of this information, and it's extremely variable across the resources which information they include out of this set of information that could also go in the provenance resource. And that's deliberate, because most systems don't track and report provenance, but some do, and we're encouraging people to, but we're not expecting that everybody will. So we have a denormalization there. You can provide the provenance resource in the HTTP header and say, here, I'm sending you this, and the provenance is in the header. And if you submit that to my server, I will use the provenance resource to populate the audit event with additional information that I didn't already have. I'm going to talk about digital signatures for a little bit. We have a signature data type which captures physical signatures, paper signatures, emotional signatures, and also digital signatures, and we use that in two places. So the signature itself starts with a type, which is a user type level signature. It's not the type of signature. Is it a digital signature or a scan of a paper signature? It's the user, it's the business type of the signature. Is it verification, or is it cosign, or whatever? And we have the instant that it was signed, which is where you need a time server to make sure everybody's on song with what the instant is. Who signed it, which is a FHIR reference to a FHIR resource about who signed it. Maybe they were signing it on behalf of somebody, and then the actual content type of the server and the actual the signature and the actual signature itself. So you can use this to carry a PNG or a GIF of a paper signature. There's people doing that, but you can use it to carry a XML or a JSON digital signature. And we have canonicalization defined that means that you can sign, which will survive format transforms. So you can sign the JSON form, transform it to XML, transform it back to JSON, and reliably get the same signature. We use this in two places. One on provenance. So a provenance resource is, hey, I'm giving you provenance information about this set of resources over there that I'm pointing to in target. And it can include, as part of that, a signature on those resources. And so that's effectively a detached signature. And you can go on the server and say, I'm looking at a resource, has it changed? I can go and look at the provenance and track back the provenance of, and look at the signatures. One thing we haven't done yet is define a canonicalization method that goes across a set of resources. We could do that, we just haven't got around to it. The other thing that we do is that we have bundle. In bundle there's a signature, and so the signature in the bundle signs all of the resources in the bundle using the canonicalization method. And you can say, I want data, or I want narrative as well. I want to ignore the narrative, I don't care about that. There's a few choices like that. Bundle as an envelope signature is much more well understood, because given the scope of a FHIR resource, I say I'm going to prescribe a medicine, and I prescribe and I sign the medication request resource. So what? Right? The medication somewhere else, the patient somewhere else, the provider somewhere else. It's actually not a lot of point signing an individual resource. You need to sign a set of resources that together constitute a coherent package of information. So you can stick them in a bundle, sign the bundle, and that's fine. And we have systems doing that today, signing bundles, envelope signatures in a bundle, using JSON or XML, that's fine. But if you actually start doing anything with that information, then you're going to send it from a server that signed that package to another server. The first thing it's going to do is re-identify all the resources and stick them in its own database, and it just broke the signature irrevocably. And we're sure we could make a signature canonicalization that dropped all the IDs on the resources and ignored all the references to resources. What's the point? So there's some real trouble here with digital signatures. So signatures on static content, which are often called documents, well, it's not quite the same thing, are very well understood, but signatures on RESTful interfaces are not. Changing the contents, we typically change the contents of stuff as it goes by on interface engines. That's what we do. You can't sign that. And then the issue of the re-identification of resources. So the digital signature part of the specification is extremely immature. Okay, last issue. Time going okay? Yes. Some resources need special handling. VIP patients, confidential records like site consults, and some restricted use data. You might say, this data, I'm giving it to you, you can only use it for research, it's not okay for you to use this for treatment. Now sometimes the special handling is implicit in the context of the application, and sometimes it's explicit or implicit in the content of the resource. But when it comes to access control engines, it's hard enough to run an access control engine without actually having to start, speculatively processing the content of a resource to find out what kind of sensitivity it might have. And so it's really useful to denormalize that and make it explicit on the resource. To have an observation which has got some code for an HIV test, well, there's heaps of codes for HIV tests. So you just explicitly label it as super sensitive because it's got HIV results in it, for instance. And so we call these security labels. So every resource has a slot where you can label it with a security label. And so here's an example of a patient. The patient resource itself is labelled with restricted confidentiality. So any system handling this should say, well, this is a confidential patient. Why would I even show this to you? Do you have the rights to see this? I expect the access control engine to do some more work about this. Typically this would be a VIP patient, although there is actually a VIP patient label. And so you can label resources with a number of kinds of information about their special security status. Now, when we first started doing this, people came to us and go, no. This is stuff that belongs in the access control engine. You shouldn't try and solve this with a label. And it's not understanding what we're doing here. Of course, all the decisions we made by the access control engine, we're just helping it out by labeling the information for it so it gets it right. And you can also label a request. You can actually put a label on the HTTP request. Say this request has special security label considerations. Access control engine will probably go, I don't think so, but it might say, oh, okay, well in that case I'll do something differently. And the classic is break the glass protocol, where you can say, I'm invoking break the glass protocol to get emergency access to the patient's record. Typically you'll get a FHIR audit, specific manual audit, stuff like that, but that's how you actually mark a request as that kind of request. In the specification, we define a set of core labels. A restricted set of security labels that every application is expected to know. Not that many people actually do this, but you should. You're required to. So we say that you should know what purpose of use is. If your application is providing treatment data, clinical treatment, then you should write an assertion somewhere down in your client layer that you don't want to ever see information labelled for research only. You should be doing that. And then also there's confidentiality codes. So every application should understand what confidentiality codes are and what they mean. And some of you might go, well, in my application I don't care, and that's fine. You can make that decision, but you can't say, I never thought about that. You're required to think about that. And then there's two particular codes that clients need to pay attention to. If you get a resource labelled delete after use, you cannot put it in your audit trail. Now you might say, well in that case I'm not going to handle it, that's fine. But you can't store it. And then of course the application, at some stage we'll get to the point of saying the server needs to know whether you actually can handle that information, you just don't want to even see it in the first place. But you can't say, oh, I didn't know about that. You're required to know about that. So there's actual obligations for everybody associated with security labels. There's 500 plus total labels, and they're growing, but the stuff that you need to know is a much shorter list. Right, so security's hard, requires clear thinking, and there's a lot of that not around. We still have ongoing work around authorization and consent, and I got a couple of minutes for questions. Yeah. Not from you, Michael, next. Okay, Michael.
We talked about restrictions with XHTML, but we now have Markdown, And Markdown implicitly includes HTML. So
Our rule on Markdown is no HTML in the Markdown. Of course, the validators enforce that, but that doesn't mean that your trading partners enforce that with the validator, although they could. That's why the validator is supported. So it's still worth being sure about that. And you should always use Markdown processes when you're using Markdown processes that you can turn off HTML processing and not allow HTML, which is an error if the Markdown includes HTML. Any other questions? All too scary to ask any questions about security. I thought again, yeah, Joel.
you mentioned role-based or organization-based. That's a topic for future exploration.
Well, we assume that people actually implementing real servers that control real data will have some kind of access control engine, but for as far as we're concerned, other than that you need to conform to the authorization agreements with the user, we assume that you'll have private agreements and they're all behind the API and they're invisible at the API level. It's an open question whether the API level should get into those kind of things or whether we'll just say it's a private business. For those of you, there's another spec running around called UMA, which is about delegating authorization and formalizing the relationship between the resource server and authorization server, a set of resource servers. But in the end, access control has to live on the resource server, and I explained why that is. It can't move away from that. The authorization server can just administrate authorization decisions. And in fact, if you're on chat.fire.org, you'll see we're discussing that right this morning with the security experts. Did that answer the question?
Well, I'm thinking of a use case that's not surrounding user access, but other levels of access, so a role or a situation level access.
Well, you can, and that's the system, equivalent to system scopes, and you can give a client system level access based on its organisational role. We just don't have anything to say about that other than that you should know what you're doing. Because, you know, that's the hard bit, knowing what you're doing. One last question then.
So another one.
No, done well, sorry.
One of the things we're running into in the UK is the concept of data ownership, and we're thinking of using security labels to define data ownership and use that as part of access. Is that something you run into anywhere else?
It actually is, and I think that it's not about security labels, because security labels are by kind rather than by instance, and almost always when you talk about data ownership, you start talking about the instance of the person or the organisation that owns the data, and so I don't think that's a good use of security label, but I'd like to talk about that, because we haven't, when we've talked about that before, people have started thinking about what that means and going, let's find some other way. So I'm quite happy, I'd like to talk about that some more. All right, thanks everyone, I hope that was useful, and you can come and ask me more questions.